My name is Khalil, and now I'm a student from Legacy of Purpose Preparatory Academy, and I am 9 years old, and my project is called Math and Piloting. So, the purpose of my project is to learn about math and pilots. My question is, why do pilots need math? My hypothesis is, pilots need math to program the plane or helicopter. And this is the information I discovered. Piloting is mathematics. You need to know a lot of math so you can be a pilot. For example, you need to know algebra, geometry, and trigonometry. Sometimes you need to calculate the distance between the sky and the ground. If you don't know math and you want to be a pilot, you better learn math. Sometimes you need to calculate the air resistance, the speed, and how fast the blades spin. Pilots know a lot of math. That's actually how you become a pilot, by studying math. Pilots use math in piloting by fuel planning, temperature conversions, replica heading, turn radius, time, speed, distance problems, and calculating your true airspeed. And time to end, I'm going to explain why I got my pictures. This picture represents the piloting dashboard. This shows what happens if you complete your plane project, and this is what it looks like in the front. This is the center of gravity. It explains the balance of the plane of the fuel, engines, wings, body, payload, vert tail, and hortail. This whole equation equals the balance of the plane, which is the center of gravity. This, however, is related to this. It talks about the center of gravity when it's landing, climbing, or already up in the sky. This is the lift, drag, and angle of attack. The lift is the turbine blade, and the aircraft wing is the drag. The low lift drag is when the turbine blade and the aircraft wing is at the same thing, and the maximum lift is when the turbine blade is higher than the aircraft wing. And the low lift high drag is when the turbine blade is short and the aircraft wing is very long. This calculates the speed. C equals 45 degrees, which is the ground speed. B needs to equal the wind speed, which equals 20, and the airspeed equals A, which the airspeed needs to be 100. This is how strong the wing needs to be, and weak the wing needs to be when it's windy. So if it's windy, when it's windy, the wing needs to be strong so it can lift more vertical. And when it's not that windy, the wing needs to be weak. And this is the distance formula. This is how pilots calculate the distance between the sky and the ground. They use coordinates, and these are the routes. This explains how planes make it to one destination without crashing to each other. Some planes turn, some planes go north, some planes go west, some planes go south, and some planes go east. Therefore, my conclusion is pilots need math for fuel planning, temperature conversions, replica heading, turn radius, time, speed, distance problems, and calculating your true airspeed. And that's my project.